All right, y'all, we're looking at the Systems of Equations test review. All right, this is in the second 6 weeks, and we're looking at this first question right here. It's asking us to solve by the method of substitution. Okay, and if we're talking substitution, then the thing that we're looking for, the key thing that we're looking for, is a single variable. Either x or y is already by itself, which is exactly what we have in problem number 1. We've already got that first equation says y equals something by itself. So what I'm going to do is I'm going to take this thing right here that y is equal to, and I'm going to substitute it in place of the y in the second equation. So instead of 2x plus y, I'm going to turn that into 2x plus x plus 1. Okay, 2x plus that whole thing. Substitute that whole thing in. I'm just plugging it into the second equation. It's still going to be equal to 7. And now the name of the game is just to simplify and find what x is equal to. All right. So I'm going to put those two like terms together right here and right here. We've got like terms in the x's. So that's going to be 2x plus 1x, which is 3x, plus 1 equals 7. And then we do a little quick subtraction and division. 3x equals 6. So x equals 2. And we ask ourselves, is that the final answer? And the answer is no. This right here, what I'm circling in red, that is only half of our final answer. Okay, that's the x value. It's going to be 2. To find the y value, we got to take this and plug it back into one of our originals. I'm actually going to put it into that top one so that it's going to become, instead of x plus 1, it'll be y equals 2 plus 1. So y equals 3. Those two things with the red circles, those are the two parts of our answer. Remember that your answer for a system is an ordered pair. It's got an x value and a y value both. Problem number 2 is also a problem with substitution, except this time we don't have x or y already by itself. What I'm going to have to do is look for a single variable. Okay, I'm looking for something like this x right here that has a coefficient of 1. And what I'm going to do is I'm going to make that x be by itself by getting rid of this minus 4y. How do I do that? I add 4y. On both sides of the equal sign, I add 4y, and on the left, all of that cancels out. We're left with x on the left, and we're left with positive 4y and positive 13. Remember that those two things are not like terms. So just like the offspring said, you got to keep them separated, okay? If they're not like terms, you got to keep them separated. So that means we've got positive 4y and positive 13 as two separate terms. But now what I can do is I can take this thing right here and I can substitute that thing in place of x in our top equation right there. So instead of 2 times x plus 3y, we're going to now have 2 times all of that plus 3y. Okay, do some quick little distribution here. And let's see, what does that give us? It'll be 8y, 11y plus 26. We subtract 26 on both sides. Y equals negative 3. We ask ourselves, is that the final answer? And the answer is no, of course it's not, because we don't have a true final answer until we have an x value and a y value both. So what I'm going to do is I'm going to take that y that we just found, I'm going to plug it back into our original right over here. Okay, instead of x minus 4 times y, that's going to be x minus 4 times negative 3. Okay, let's see, we do that distribution, we got negative 4 times negative 3, that becomes x plus 12 equals 13, so of course x is going to be equal to 1. Those two red circles are the two parts of our answer, 1 and negative 3. Moving on down, number 3. We've got another problem. We don't have x or y by itself, but I do see right here, I do see this y in the top equation has a coefficient of 1 by itself. So what I'm going to do is I'm going to subtract 3x on both sides. Okay, that'll give us y by itself we're going to have negative 3x and positive 4. Remember, they're not like terms. You got to keep them separated. So we take that one, and that's what I'm going to substitute in right there in place of y. Negative 6x minus 2 times all of that business. All right, we multiply everything out, simplify down as much as we can. Negative 6x. We distribute that negative 2. That'll be plus 6x and minus 8. Well, look at what we've got here. I see negative 6x and positive 6x. Those two things are going to cancel each other out. We end up with something right here, negative 8 equals negative 8. And we ask ourselves, is that true? Well, yeah, obviously it's true. Okay, if negative 8 is equal, negative 8 is negative 8. Of course they're equal to each other, right? So what this means for us is that it doesn't matter what x and y that we plug into this. If it fits in the first one, it also fits in the second one. Okay, no matter what x and y you pick out, if it fits in the first equation, it's always going to fit in the second equation. So that means what that means for us is that it's not going to be an answer that goes in an ordered pair like this. This is going to be infinitely many solutions. Okay, so if you do that substitution and you get to something that is an objectively true statement, you say there are infinitely many solutions. Roll on over now to number 4. Okay, on number 4, if we're still doing substitution, I see a coefficient of 1 on the x in our bottom equation. So I'll subtract 4y on both sides here. That's going to turn this equation into x equals negative 4y minus 4. Remember, the thing that we just subtracted has y, and the number negative 4 does not. Those are two separate terms. They're not like terms, so we can't put them together. So I take this right here, and I substitute it in place of the x right there. So instead of 3 times x plus 5y, we've got 3 times all of this business plus 5y. There we go. Do some simplifying down as much as we can. And let's see, that gives us negative 7y minus 12. Negative 7y equals 14. And that means y is negative 2. Remember, we're not finished yet. That's only half of our answer. It's only the y value. We've got to still have an x. Okay, I'm going to take that. I'm going to plug it in right up here in our original. Okay, x plus 4 times that negative 2 that we just found. And I've got x equals 4 right there. So there we have it, 4 and negative 2. All right, what I see starting in number 5 is solving systems by elimination. This is the main event that we've all been waiting for because everybody likes elimination better than substitution, right? Okay, the thing that when we were doing substitution, we were looking for those single variables, x equals something or y equals something. And if you didn't have that already, you could get there if you had a coefficient of 1. So you were looking for those single variables. When you're dealing with elimination, you're looking in both equations, and you're not just looking for a single variable, you're looking for opposite terms. Okay? And so I look at problem number 5, and I don't see any opposite terms, but I do see that both of those equations have 3x. So what I can do is I can take one of those equations, I'm going to pick the top one here, and I can multiply every single part of that equation times negative 1. And it doesn't actually change any of the numbers, but what it does is it makes all of those positive terms negative. And so instead, our new equation, our modified version of that top equation, is going to be negative 3x minus y equals negative 2. Okay, so now when I do that step where I add the equations together, all of that business, I'm now dealing with those bottom two, the second one that it gave us and our modified one, where now the x's are going to eliminate. Okay, if those x's eliminate each other, we are left with 2y minus y, which is 1y. 7 minus 2 equals 5. There we have it, one of our answers, y equals 5. That's part of our final answer. The other part is where we plug it in to one of our originals. Okay, I'm going to go ahead and use, let's see, I guess let's use the original that we actually modified on. Okay, we'll use the one up there. We'll plug that in, or no, not in place of x. We'll plug it in place of y right there. So instead of 3x plus y, we've got 3x plus 5. And we subtract 5, 3x is equal to negative 3. So x must be negative 1. And there we go. Our two answers, or the two parts of our answer, x is negative 1, y is 5. Problem number 6. Once again, we do not have opposites, but I see in the y variable right there, I see positive 4 and negative 2. What if I took that second equation and I just multiplied the whole entire thing times 2? Okay, if I multiply every part of that equation times 2, I now have 10x, I have minus 4y, and I have 36. Okay, so instead of using that middle equation, we now have opposites in the y. So when we do that step of adding our equations together, those y's are going to get eliminated. We've got 3x plus 10x. We'll have negative 10 plus 36. And there we've got it. We do some quick division. X is equal to 2. Boom. Plug that one in right there. Last step is to take that, put it back into one of our originals. I'm going to use that one right there. Instead of 3 times x, we've got 3 times 2 plus 4y. So 6 plus 4y. We subtract the 6. Negative 16. Y is negative 4. And there we've got it. Negative 4. All right, going with elimination once again on number 7. I see two different ways we can go about this. Okay, it's going to end up doing the same thing both ways, and you'll see what I'm talking about here in a second. Okay, what I'm going to do is I'm going to multiply the top equation times negative 3. Okay, we multiply times 3 so that it makes 6 and 6 in the x's, and we multiply. We make sure that 3 is negative so that it'll flip the sign and it'll be 1 negative 6 and 1 positive 6. Okay, so we make sure every single thing in that top equation gets multiplied. That makes it negative 6x, makes it plus 12y, remember, because we've got a negative and a negative, equals, let's see, what does that leave us? Negative 3 times 8, negative 24. All right, now let's do that thing where we add them together. All right, that step where we add our equations together, we're no longer using this top one, we're using our modified one now. 6x minus 6x is 0. The x's are eliminated. We've got minus 12y plus 12y. Both of them get eliminated. So we ask ourselves, what does that leave us on the left side of the equal sign? There's nothing there. It's 0. On the right side, we've got 10 minus 24, that's negative 14. So we look at this and we ask ourselves, how in the world is 0 equal to negative 14? And the answer is that it's not. Okay, the simple answer is it's not equal to negative 14. That's not how math works, right? That's not how just regular old adding and subtracting real numbers doesn't work that way. So if you end up with something like this, That is something that is obviously false. Okay, this is an objectively false statement, right? So that tells us that there are no solutions. There is no solution to this system of equations. Okay, you could also hit them with this whole symbol right here. You've seen it before. It's this thing. No solution. Okay. Number 8 can be a little bit tricky because you got to watch out for something like this. On the top equation, you have negative 3x plus 4y. You have x and y both on the same side of the equal sign. On the bottom equation, you do not have that. Okay? You need to make sure, if you're trying to do elimination, that all of your variables are lined up with each other. Okay, so what I'm going to do is I'm going to modify this bottom equation to make it 6x and make sure that all of our x's and y's are on the same side, just like the top equation. Okay, if you've got 6x, I'm going to subtract 8y on both sides. Minus 8y. So it makes it 6x minus 8y equals negative 8. Okay, so we're no longer using this middle equation. We're using the top one that it gave us and our modified one. Now we've got that. It's not that far off. It's not super far off from us doing elimination. Because what I can do is I can multiply this top equation times 2. Okay, if I multiply that times 2, every single part of it is going to become negative 6x minus 8y equals 8. Okay, if we're doing it that way, the x's are what's going to eliminate. You can see that we've got positive 6x and minus 6x. Hey, be careful on those y's. Be really, really careful on those y's. Oh, you know what? You know what? I made a mistake. I was wrong. Y'all, excuse me. I'm terribly sorry. I made a mistake. Look at this right here. When we multiply everything times 2, that becomes plus 8y. And what that does for us is it makes it to where our x's and our y's both get eliminated. Just like we had a couple of problems ago, when the x's and y's both get eliminated, we are left with nothing on the left side. We've got 0 on the left side. But this time we also have negative 8 plus 8, which is 0 on the right side. 0 equals 0. That's one of those objectively true statements. So that means this right here has infinitely many solutions. Okay, remember, after you do your substitution, after you do your elimination, if you end up with something like that, an objectively true statement like 0 equals 0, there are infinitely many solutions. So we're not worried about this right here. We're not worried about the ordered pair. We would just write that there are infinitely many solutions. All right, moving on. Numbers 9 through 12 right here are using whatever method we like best. Okay, just whatever method we want to deal with, substitution or elimination. Now, I know most of the time people favor elimination over substitution. Okay, so if that's possible, if it's reasonable to try and do that, I'll give it a shot. Okay, but sometimes you're going to find that substitution really is the way to go. So looking at number 9, I can see that we've got, I'm looking at the y variable here. I see minus y and plus 3y. Well, what if I took that top equation? If I'm doing elimination, I can take that top equation, multiply everything times 3. And look at what happens after we modify that. It becomes negative 12x. It becomes minus 3y. It becomes positive 15. Look at what happens when we add these equations together. We've got another one of these special situations. When we add the equations together, x's eliminate, y's eliminate, and negative 15 plus 15. The constants eliminate. Everything gets eliminated. We've got 0 equals 0 again. There it is, folks. Infinitely many solutions. Moving on to number 10. On number 10, we can see some things getting a little bit tricky for us. Okay, here's what I'm going to do. I'm looking at the x's. Okay, when I look at those x's, what I can do is I can multiply the top times 3 and the bottom equation times 2, and that'll give us 6x in both of our equations. Okay, so if I multiply the top times 3, well, actually what I'm going to do is I'm going to multiply the top times negative 3 so that we can flip the signs also. Okay, I'll do this one times negative 3. That'll make it negative 6x minus 15y equals negative 9. And if I do the bottom one times 2, that'll make it positive 6x minus 8y. And that'll be 32 on the other side. Okay, so now that I've modified, this time I modified both of my equations. Okay, and now I can do some elimination. Get rid of those x's. Let's see, negative 15 and negative 8, that will be negative 23y. Negative 9 and 32 would give me positive 23. That means y is going to be negative 1. Okay, after I've got my y value, I'm going to do whatever I need to do, plug it back into my originals so that I can get, the x value also. I'm going to plug that one in right there. Instead of 2x plus 5 times y, I'll make it 2x plus 5 times negative 1. And let's see, 2x minus 5. And we divide. X is 4. Those two things that are circled in blue, that's the two parts of our answer. 4 and negative 1. Problem number 11. Problem number 11, we've run into the same issue that we had on problem number 8. Okay, we need all of our x's and y's to be on the same side of the equal sign. So what I'm going to do is on this top equation, I'm going to subtract 2y on both sides. Okay, on the top equation, instead of 5x equals something, I'm going to go subtract 2y on both sides and make it 5x minus 2y equals, well, on the right side, when we subtract 2y, that leaves us with nothing. So it just equals 0. Okay. On the other equation, I'm not actually going to modify. I'm just going to rewrite over here. 3x plus 7y equals 41. Now that we've got everything lined up, everything looking good, we need to figure out how can we create opposite terms. What I'm thinking is let's multiply the top. Okay, what I'm thinking is let's try and eliminate the y values. Since we already have a negative on the top and a positive on the bottom equation, let's try and eliminate the y's. What I'm going to do is I'm going to multiply the top times 7 and the bottom everything times 2. And that'll create negative 14y and positive 14y. Okay, let me rewrite that. I'll rewrite it down below. The new top equation is going to be 35x minus 14y. 7 times 0, still 0. On the bottom, that's going to become 6x plus 14y equals 82 down bottom. Okay, we do some quick math right here. The y's get eliminated. 35 plus 6 gives us 41x equals 82. And it seems like this is such a big number, such a complicated set of equations, but it's really not, because y'all, x is just 2. That's all it is. When we do that quick little division, x is just 2. Okay, and we can take that x, we can plug it back in up over here. 5x equals 2y. Well, that's 5 times 2 equals 2y. Y'all, 10 equals 2y. What does that make y? It's 5. That's all it is. Those two blue circles, that's the two parts of our answer. 2 and 5. Number 12, oh thank heavens. On number 12, you know what, y'all? It got me. They got me. They pulled the trick on me that I thought that I know they're going to try and pull on you too. Okay? Look at this. They swapped around the placement of x and y. Look in this top equation. It gave us the y first and then the x term. Oh, they almost got me good. Okay, so what I'm going to do is I'm going to rewrite that in the right order. Okay, I'm going to rewrite it down below. It's going to be actually negative 3x plus 1 positive y equals 0. Oh, y'all, that's a sneaky, sneaky trick, and it almost got me. But you got to watch out for something like that, okay? We're not dealing with that equation anymore. We've got the one down bottom. What I'm going to do is I'm going to take that bottom equation and multiply it times negative 3 so that we can create opposites. If we do everything times negative 3, we're now going to have positive 9x. We're now going to have minus 3y. We're now going to have 0 because that's still going to be the same. Okay, that means we're no longer dealing with this equation. We're dealing with this, we're dealing with this one down bottom. We add the equations together. The y's get eliminated. You know what I just realized, y'all? This system of equations right here, I'm going to go ahead and finish it out doing this elimination method, but then I want to go back to the beginning and show you substitution. This is one where it might have actually been easier to just do some quick little substitution. Okay? I'm going to finish this out and just show you. We'll have 13x equals 26. So x equals 2. X is equal to 2. I'll plug it back into one of my originals. I'll actually use this modified original right here. We'll go 9 times 2. 9 times 2 minus 3y equals 0. 18 minus 3y. Subtract 18. Y is equal to negative 6. No, excuse me. Y is equal to positive 6. Okay, I want to do this problem again though. I want to do it doing some quick substitution. Okay, let's look at what we started off with. Up here, up at the top, we started off with this. Wouldn't it be quick and easy to just turn that into y equals 3x? Couldn't we just take that and turn it into y equals 3x and then take this, substitute it in right there? 4x plus 3 times 3x equals 26. That would actually be a pretty easy one to solve, wouldn't it? And you would still end up with the same thing. You would still end up with 13x equals 26. The only difference is now you get that x equals 2. You could plug it back into one of our originals way up here at the top. Figure it out nice and quick and easy. Okay? So that's what I'm saying is look at the problem. Try and be careful about it. Okay? Take some time and think about different strategies that you could put into these problems. Let's go ahead and do these reviews. Okay, these are review problems just real quick. These are from our previous units that we've done. The first one is describing the transformation. This is an absolute value function. Okay, the first thing I notice is the negative sign out here in front. So that means it's going to be reflected. It's going to be reflected over that x-axis. I also see a fraction out in front of it. Okay, when you have a fraction coefficient, that means it's not going to be a vertical stretch. It's going to be a vertical shrink. Okay, a vertical shrink by a factor of 2/3. Next thing I notice is a minus 12 on the inside. Okay, remember that your inside anything that's inside your grouping symbols, any of those changes, adding or subtracting numbers inside, that is talking about your left and right shifts. But you also have to remember that insiders lie. Okay, so because it says minus 12, the first assumption is that you're moving to the left. But because insiders lie, we have to know that this is a shift to the right. We shift to the right by 12 units. And on the outside, that's our up and down. The outside, our up and down shift, we shifted the whole thing up by 15 units. Roll over to number 14. It gives us F, it gives us G. It asks us to find F minus G. Y'all, the name of the game is laying all this out and combining like terms. Okay, if we're doing negative 11x plus 19, that's F minus all of that stuff in G. We're subtracting 12x minus 15. All right, so what we need to do first, actually, is we're going to go ahead and distribute this negative. Make sure this whole entire thing in parentheses is getting subtracted, not just one part or the other. We'll make it negative 11x plus 19 minus 12x plus 15. You've got a negative and a negative, so it becomes plus 15 right there. Okay, so it's just combining like terms, all right? We'll have negative 23x. When we combine the x terms, I'll cross them out, get rid of them. Plus 19 and plus 15 will give us a total of plus 34. So there we've got it. All right, that is our entire test review. Your test, when you actually take it, will be almost exactly like this. There will be some problems where you do substitution, some problems where you do elimination, some problems where it is up to you to decide which one to do. Okay, it is all your personal preference on those ones at the end. And then at the very, very end, there's a couple of review problems, kind of like this. Okay, it's going to be just like this. So I encourage you, as you're working through these problems, send me an email, ask me questions, do whatever you need to do to understand this before you actually take the test. Okay, I'm a teacher, not a mind reader. I don't know what you don't know if you don't let me know. Okay? I don't know what you don't understand unless you tell me. Okay? So ask me questions and let's get this figured out before you take that test. All right? That'll be all for today. Y'all have a good one.